All right, 8.1, find angle measures in polygons. That is our objective. So we're getting away from the trig, back to what more people think of as traditional geometry. Ari? You can do what?
You can subtract 19 and 80 from 180.
Okay, on the first warm-up, if we know two angles in a triangle, we could subtract the two angles we know to find the third angle from 180, because we know all the angles inside of a triangle add up to 180. So minus 80 minus 19, or you could add those together first, then subtract from 180. Either way, what do we get? 81 degrees. On number 2, we technically have a couple different ways we could go about solving it. What do you want to do? Detrana?
I did 180 times x and then 180 times y.
Okay, so we can distribute the 180 into the parentheses. That's one way of doing it. If we do that, 180x minus 360 equals 1,980. Then we would have to add 360 to both sides. 180x equals, and our last step would be divide by 180. What do we get for x? 13. Did anybody go about it a different way? Brianna?
I divided 19 by 180 first.
Good. That would be the other way to do it. Maybe the easier way for some people. We could go ahead and divide off the 180 from both sides first. And then after that, all you would have to do is add 2 to both sides. It doesn't really matter to me as long as you're showing me some work so I know what path you took to get there. Questions on 2? All right, on number 3, the value of x. What do we know about the x angle and the angle they gave us? They're on a straight line, which means they have to be supplementary. They're a linear pair. They have to be supplementary. So 180 minus 54 gives us 126. Questions, concerns about any of our warm-ups? Ready to move on? Okay. Recall that a polygon is a closed plane figure formed by 3 or more line segments where each side intersects exactly 2 sides, one at each endpoint. So the definition is a little long. Most of you would be able to recognize a polygon if you saw one. The reason it gets so detailed is so that you understand certain things are not polygons. Meaning, if it has a curve in it somewhere, it's not a polygon. So this is just kind of an aside, not a polygon. Here are some things that would not be polygons. If it's got a curve to it, so a circle is not a polygon, or an oval, or a semicircle, meaning it's partially straight and then it curves out. Anything with a curve is not a polygon. Anything that doesn't meet all of the endpoints, meaning a shape like this, it's not really a shape at all. It's just a collection of segments. If it's open to where you could walk inside, it's an open door, not a polygon. If the segments end up intersecting each other, like these, the lines cross each other, not a polygon. Individually, we would have 2 triangles here, but if you take it as one whole thing, not a polygon because it crosses or intersects itself. Okay, so that's why the definition gets really wordy there, so that we understand that these certain things would not fit that description. Questions about what is not a polygon? Okay. Many of these, if not all of them, we probably already know the name of. If you have 3 sides, what kind of polygon do you have? A triangle. 4 sides gets a little tricky for some people. Not for this class. It's a quadrilateral. Later on, we will talk about the defining characteristics that make something a rectangle, lateral. Make something a rectangle, a square, things like that. But if in general all you know about it is that it has 4 sides, it's just a quadrilateral. 5 sides, pentagon. 6 sides, hexagon. Make sure you know how to spell these. 7 sides, anybody know? Heptagon with a PT. Heptagon. 8 sides. Octagon. 9 sides. Nonagon. Bless you. 10 sides. Decagon. Anybody know 12? A dodecagon. Anybody know? To me, that's a little bit backwards. If it has n sides, it's called an n-gon. So I'm going to change that. If there are n sides to it, it's an n-gon. Meaning, if it were to have 52 sides, we would call it a 52-gon. Not 52-a-gon, just 52-gon. Just as an example. So if it's not one of the ones given, so that would even include 11. 11, for whatever reason, there's no universally accepted name for. 11, 13, 14, 15, any other number not on this list that would be a polygon is just that number dash gon. Questions, concerns, need more time with our definition or names? Okay, we'll keep it moving. 2 vertices that are endpoints on the same side are called consecutive vertices. So that means they are part of the same line segment. So can anybody give me an example of 2 consecutive vertices, Majay? B and C would be consecutive vertices. B and C, what would be another pair? C and D. We could do this the whole way around this pentagon. Okay, so I'll just put etc. They've got to be part of the same line segment. So C is consecutive to both B and D. Remember, vertices are points and points. So if you're naming vertices, you should only be using one letter. A diagonal of a polygon is a segment that joins 2 non-consecutive vertices. So when you're naming diagonals, you're naming segments. So what would be a diagonal of this pentagon? Anybody a little louder? Because I can't hear you when you whisper. B-E, very good. That would be one. B-E would be considered a diagonal. Segment B-E. Which other one, Brianna? Okay, B-D is another one. B-D. A-D would be one. Oh, that's a little off. Still off. Okay, would something like BC be a diagonal?
No.
Why not? Because why? Okay, they're consecutive. They're not non-consecutive. They're actually a side of the pentagon. Okay, so there are more diagonals, of course, so you could list them all out if you need to or want to, but those are some examples. Questions, concerns, need more time with this slide? For sure. Okay. Next slide. How many non-overlapping triangles can you draw in a pentagon? So if I make a pentagon, I better have how many sides? 5. So I'll just draw myself a little pentagon. Doesn't have to be perfect, but it does need to have 5 sides. So the question is, how many non-overlapping triangles can you draw? So I'll give you a minute to think about that. Maybe sketch in your triangles on your pentagon. It shouldn't matter what you drew your pentagon looking like, whether it's all the sides are exactly the same, whether it looks a little wonky like mine does. It shouldn't matter. See how many non-overlapping triangles you can fit in a pentagon. Okay, so if we're not creating any new points, we're only using the points that we have, you could pick any vertex to start from. So if I start from this one on the side and I draw in my 2 diagonals from that side, how many triangles did I make? 3. Now if I wanted to instead start at a different vertex, I would again only be able to fit 2 diagonals. And how many triangles do I have? 3 again. Okay, so it doesn't matter which vertex you start from. But at this point, if I were to try to make any more diagonals, what's going to happen to my triangles? They start overlapping, so I can't do that. Okay, so the answer should be 3, assuming we're not creating any new points, meaning I'm not going to just split this triangle down into 2 of its own. That would make it more complicated. There is a reason that we just had to answer this question, and it comes up on the next page. So just before I flip to the next slide, how many degrees are in each one of these triangles? Whoa. What? 180, right? In any triangle, there's 180 degrees. And so if I were to add all the angles up from each of these triangles, I would end up with the degrees overall. If I added those 3 together, add this one, add those 2, add those 2, I would end up with all the degrees for my whole pentagon. If you can see that and understand that, that might help the polygon interior angles theorem make a little bit of sense. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. N being the number of sides. That's why they call it an n-gon. However many sides it has. So for a pentagon, we had how many sides? 5. And if you take 5 minus 2, you would get 3, because that's how many triangles we could fit in there, times 180, because that's how many degrees there are in a triangle. You see how these are related? Number of triangles you can fit inside of that polygon times 180 is how you would get how many degrees should be inside that whole figure. A corollary to that would be the interior angles of a quadrilateral, which some of you may have already known. The sum of the measures of the interior angles of a quadrilateral is 360 degrees. They came up with that because a quadrilateral has how many sides? 4 minus 2 is 2, times 180 is 360. So usually we just have it memorized that there are 180 degrees in a triangle, 360 degrees in a quadrilateral. The ones beyond that, yes, you could memorize them, but usually we just fall back on the formula. Some of them will start to look familiar because you'll use them over and over. Questions, concerns, need more time? Okay, we'll keep it going. Find the sum of the measures of the interior angles of a convex hexagon. Now, we haven't really talked about convex versus concave recently. Do we remember what convex means? Good. All the angles point out, meaning I'm not going to have a shape where they would point inward on each other like this. Okay, we can't have it point inward. This only works if all the angles go outward. You don't really need a diagram for this because we can just use that formula. How many sides does a hexagon have? 6. So we plug in 6 for n. By order of operations, what should we do first? In those parentheses, 6 minus 2 is 4 times 180 is 720. So there are 720 degrees total inside any convex hexagon. Again, if you really want to take the time to memorize that sort of thing, that's fine, but usually we just fall back on the formula for shapes bigger than a quadrilateral. Questions on one? On we go. Find the value of x. Okay, what kind of polygon is this? A quadrilateral, which means that all the angles should add up to 360. So much like we did when we had triangles, we'll just take that sum of 360 and do what with all the angles we know? Okay, you can add them up and then subtract one big number. You could subtract them one at a time. Either way, 135. Either way, what do we get? 42 for x. Questions, concerns? Pretty straightforward. Okay. Another find the value of x. This one's a little more challenging. Will all of these angles add up to 360? No, because this is not a quadrilateral. Doesn't have 4 sides. How many sides does it have? 5. If you're not great with counting sides, you could instead count angles. That's easier for you. 5 angles means it should have 5 sides. So, we can use our formula, 5 minus 2 times 180, to know how many degrees should be inside of that pentagon altogether. What do we get? 540 degrees altogether. So we know that if we add all of these angles up, it should equal 540. I'm fine with you combining like terms as you go on this one. Okay, if I take 3x, what should I be combining with that one? 2x. So 3x plus 2x is 5x. Plus, add up all of the whole number integer angles. 64 plus 86 plus 110. 260. And that should equal the 540. Okay, subtract 260 from both sides. What do you get? Okay, bless you. Nope, not 2x. 5x equals 280. Then we would need to divide. X equals, are we all okay with x equaling 56? Okay, now they just asked for the value of x, so we can just stop there. If they had asked for any of the missing angles, you would have to plug 56 back in for x and find them. So make sure you're paying attention to what the question wants. Questions about example 3? Okay, I know we got several new ideas today, but hopefully they're not too challenging. Number 4 switches it up a little bit. The sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Classify the polygon by its number of sides. So we are going to use that same formula. So n minus 2 times 180, that gave us the sum of the angles. This time they gave us that sum. And they are asking us to classify it by its number of sides, which means we need to find n. So this one will be set up just a little bit different. We're trying to find n. I don't know what it is yet. But we know that this needs to come out to equal 1,260. If you have questions about the logic getting me to that point. Okay, now much like the warm-up, you have two different ways you could solve this. I would probably recommend dividing both sides by 180 first. Makes your numbers smaller right away. So we're left with n minus 2 equals what? 7? Then what do we need to do? Add the 2. N equals. Have we answered the question? No, the question didn't say find the number of sides. It said classify it. This would be a nonagon. Make sure you answer the question that was asked. Questions, concerns, need more time? We got another new idea to talk about. The exterior angles theorem. The sum of the measures, didn't mean to tap that. There we go. The sum of the measures of the exterior angles of a convex polygon with one angle at each vertex is 360 degrees. So that means it does not matter how many sides there are. You're always going to end up with an exterior angle sum of 360 as long as it is convex. So they showed us a pentagon here. It would probably be pretty obvious if we did it with a quadrilateral like a rectangle. If I were to extend each of these, bless you. Bless you. If I extend each of these sides, of course, those were all right angles, so these are all right angles. We get what I'm saying here? 2, 3, 4. So this works with any convex polygon. Could be a triangle, quadrilateral, pentagon, hexagon, any of them. Always, always, always the exterior add up to 360. Questions, concerns, need more time with that? Okay. Bless you. Goodness. All right, so on this diagram, are we shown interior or exterior angles? Exterior angles. So we know that the exterior angles need to add up to 360. So again, if you combine like terms as you set this up, that's fine. What terms could be combined? 2x and x gives me 3x. We could also combine 89 and 85 added together gives me 174. Bless you. And that should all equal 360. Again, it adds up to 360 because those are exterior angles. It really doesn't matter that this happens to be a quadrilateral this time. To solve this, we would subtract the 174, so 3x equals 186, and then we would divide x equals, beautiful. Questions, concerns? Need more time? Warm fuzzies all around? Okay. One more. A stop sign is shaped like a regular octagon. Find the measure of each interior angle and each exterior angle. Now, the idea of it being regular is important. Does anybody know what regular means? Kara?
Means like
Everything's congruent. So all the sides are congruent to each other. All of the angles are congruent to each other. So if you need to make a note of that as a reminder, all sides are congruent to each other. Bless you. All angles congruent to each other as well. If that wasn't the case, we wouldn't necessarily be able to do what this question is asking. Let's start with the interior angles. How do I want to phrase this? What's the sum of the interior angles? What? How do we find that? 8 minus 2 times 180. Okay, so we've got an octagon, which means we have 8 sides. 8 minus 2 is 6. 6 times 180, we got 1080 for the interior angle sum. Are we all okay with that? Okay, so that's all of the interior angles together. What do you think we need to do to that to find one of them? Do what? Okay, divide it by 8. So to find one of them, we take 1080 divided by 8. What do we get? 135 degrees. So that would be for one interior angle. One interior angle would be 135. Wow, that's not, there we go. 135 degrees. Okay, what's the exterior angle sum? 360. If you're finding one exterior angle, what do you think you do? Divide it by 8 again. And what do you get? 45. What do you notice about one interior and one exterior angle? Very good, they're supplementary, and that should make sense to us, because if we were to draw this, which mine will not be regular, but if we were to draw, that's not even an octagon, I'm not making enough sides. Here we go. If we were to draw this out, and we look at one interior and one exterior angle. So let's say I take this side and I extend it out. One interior angle and one exterior angle make up a straight line, so it should make sense that they are supplementary. So the other way of doing this would be to find an interior angle and then subtract it from 180. You'd have an exterior angle. Questions, concerns about what I mean by that? Okay, so technically today we got quite a bit of new information, but much of it should have been at least a little familiar, like how we name them, classify them, sides. Do we have any questions, concerns at the moment? Okay.